Welcome to all. Here we are going to learn the CHO 150 course Basic Organic Chemistry. Last time we learned about the carbocations, carbanion and the free radical. Today we start the new reactive intermediate, that is carbene. So let's start our topic with the carbene. What is the carbene? Carbene is a molecule containing a neutral carbon atom with a valence of 2 and 2 unshared valence electron. What is the carbene? Here this is a divalent compound contains a two free lone pair of electrons, and here the two valence, that is the R1 and R2, these are the two valence. The carbene are uncharged electron deficient molecule species that contain a divalent carbon atom surrounded by a sextet of electron and two substituents. Here there are the two substituents there, and the total number of electrons are 2 electron from carbon number 1 R1 and 2 electron from R2 and 2 electron that is in a free state. That means they show the sextet, that is a 6 electron. Here these are some examples of the carbon. This is a methylene carbon. There are the two substituents of the hydrogen. Here two substituent of hydrogen, carbon having a free electron. This is called as a carbene, methylene. Here then dichlorocarbene, there is a two chlorine is there and carbon which is in a free state. Here these are some examples of the carbene. Let's we learn the types of the carbene. The carbene are called the singlet and triplet carbene depending on a electronic spin. The triplet carbene are a paramagnetic. The total spin of a singlet carbene is 0, while that of the triplet carbene is 1. Okay. Here the bond angle are 130 to 150 degree for a triplet methylene and 100 to 110 degree for the singlet methylene. The bond angle of triplet methylene is what? 130 to 150 degree, and for the singlet methylene is what? 100 to 110 degree. The triplet carbene are generally stable in the gaseous state, while the singlet carbene occur more often in a aqueous media. Let's we learn about a singlet state and triplet state of the carbene. Here what happen in case of a singlet carbene? This is the carbocation like in nature, which having a trigonal planar geometry and the electrophilic character. Here this is the singlet carbene which having sp2 hybridized. How it form? Here this carbon, which is ground state electronic configuration, is like this, 2s2 and 2p2. Okay, what happened here in case of singlet carbene? Here these in hybridized state, these are combined together and there is a formation of sp2 hybridized state. Okay, and a hybrid orbital, and that's why they having a structure trigonal planar. Here in this case these two unpaired electron are combined with the another substituent like the hydrogen or the another chlorine compound, etc., and there is a formation of sp2 hybrid orbital. Okay, and here this carbon contain this free electron in a one orbital, that is a sigma orbital. Here in that case these two electron or the electron pair which is present in opposite spin in a one orbital. Okay, and that's why here the spin denoted as a s, which is equal to plus half plus half, which is equal to what? 1. Okay, that's why here this is called as a singlet, and their spin is 0, s is equal to 0. Okay, here that's why they shows a singlet carbene, only it gives a singlet. Okay, 2 Ni plus 1, s is equal to what? 2 Ni plus 1 plus 1 is equal to what? Plus half minus half is 0. That's why 2. Okay, what happened here? What it shows the singlet? Because what happened? There is a 2 electron in opposite spin. That's why the spin is equal to what? 2 Ni plus 1. According to that rule, here how many electron is there? 2. 2s plus 1. What is the formula for this calculating the spin? This is s is equal to 2s plus 1. Okay, here what is the s? How to calculate this s? This s is equal to plus half minus half. Why? Because uh, here because here these two spin are which is in a opposite spin. Why? Because these two electron which is present in the s orbital having a opposite spin, one spin having a plus half value, another spin having a minus half value. That's why s is equal to what? 0. Okay, s is equal to here it is 0, and that's why if we put the value into this formula, then what happen? We get here which is equal to 2 into 0 plus 1, which is equal to 1, and that's why it gives us the singlet. Understood? This gives us a singlet. That's why it is called as a singlet carbene. Understood? Here, and that's why they having sp2 hybridized. That's why they having a trigonal planar structure. This is electrophilic. The singlet carbene generally participated in a electrophic reaction and either electrophile or the nucleophile. In case of triplet state, what happened here? This carbon which is having ground state electronic configuration is like this. 2 electron is here, 1 electron is p, and another electron is in a p. Okay, then what happened? This electron from the s excited to the p orbital, and in hybridized state what happened here? This electron is here, this electron is excited, and there is a formation of like this structure. And here there is a combination of these two electrons, one electron of the s and one electron of the p, and they shows sp hybridized orbital. They shows what? Sp hybridized orbital. And this sp hybridized orbital which is having a shape linear. They having a shape linear. Okay, and this 2 electron which is present in the p orbital. Okay, and here that means they present in the p orbital, not the s orbital, and that's why here these two and these 2 electron present in the two different p orbital, having maybe in upper same position or the different. Okay, then how to calculate the spins here? Yes, here here this is the triplet carbene having sp hybridized, and that's why this is what the geometry is linear. Okay, here this having a same direction, the electron having a same direction, and that's why yes having the s value is what? Plus half is equal to 1. Okay, and that's why here delta s is equal to, or the spin which is equal to what? 2s plus 1, which is equal to what? 2 into 1 plus 1, which is equal to 3, and that's why here it gives a triplet state. Okay, it gives what? A triplet state. Understood why this carbene gives two types of a state. First is singlet and second one is a triplet. Triplet state, that means the two electron which is present in two different p orbital like this manner, and that's why their spin value is 1, and that's why they gives delta S value it's 3. That's why they gives the triplet state. Okay, and the triplet carbene have to go through an intermediate with two unpaired electron, whereas the singlet carbene can be react in a single concerted state. This is the structure of a triplet carbene. This is first, that is a singlet carbene, two electron present in the one orbital. Triplet having a two different maybe structure. That means in first triplet state, this two electron which is present in the two different p orbital having upward direction, or this triplet carbene which is present in the two different p orbital having a downward direction like this manner. Okay, then here this singlet carbene are the spin paired, and the molecule adopt the sp2 hybridize. We learn already this. And the triplet carbene that have a two unpaired electron. The singlet carbene, which is what the paramagnetic, sorry, singlet carbene is a diamagnetic what singlet, and the triplet carbene is a paramagnetic in nature. Okay, here the what is the example of the singlet carbene? The singlet carbenes are mostly CH2, CHPH2, CHR are substituent attached to the carbene, that is a singlet carbene. And the electronegative atom attached to the carbene, that is what the triplet carbene, that is CCl2, CHCl, COMe twice electron accepting group attached to the carbene, that is the triplet carbene, and electron donating group attached to the carbene, that is what, or R group attached to the carbene, that is the what, the singlet carbene. Okay, this is the structure of the singlet and the triplet carbene. Here, this further, the metal carbene complexes have been classified into the two broad classes. First, there is a Fischer type of, and second is a Strock type of the carbene. This is not very much important, only for your sake of knowledge. First, the Fischer, and this is the second one is the structure of the Strock carbene. Let me learn first Fischer carbene. The Fischer carbene complexes are a low valent complexes. That means their metal, central metal having a low oxidation state. This is the W, tungsten is the central metal atom which having a low valent complexes, stabilized by a strong accepting ligand. Stabilized by what? Strong accepting ligand. Here the one or two heteroatom, that is the oxygen, nitrogen. Here the oxygen is there, oxygen, nitrogen, sulfur are bonded to the carbon atom and stabilize it by delocalizing the positive formal charge. The carbon is formally regarded as a neutral ligand. According to the Fischer carbene are relatively it is a inert and tend to react with the electrophile. Mostly here this carbene is react with the electrophile. In general, the Fischer carbene are the 18 electron coordinatively saturated complexes, and therefore here the nucleophile attack at the metal is not possible. Here this is a electrophile attack to that metal, not the nucleophile. Okay, next is what, the Fischer carbene, Strock carbene. This is the example of the Strock carbene. The Strock carbene complexes are the early transition metal complexes having high oxidation state. The metal having high oxidation state. Here, they are stabilized by a strong donor ligand. The most of these complexes have an electron count below 18 or and are thus coordinatively unsaturated. These are what? Coordinatively unsaturated. That means they are having a double bond. Okay. Here, therefore, the nucleophilic attack at the metal is a possible metal which have a nucleophilic attack because of the electron deficiency. Okay, this is about what the carbene. Thank you very much for attending this lecture. Next time we learn about the nitrine and also the comparison between carbene and the nitrine. Thanks for watching this lecture. Must watch the lecture and comment as writing your name. It's compulsory to all MSc first year student. Thank you.